Hello, teacher. I hope that you are having a good day. Uh, but at this time, I'm doing this exam. I'm going to explain to you the application of functions, two problems of that. For the first one, we have the linear function for the engineering, and the problem two will be the quadratic function for the science. Well, problem one, we have the electrical resistance in a copper wire. We need to read it to understand. So, an electrical engineering is designing a circuit for a building. The resistances are in ohms. There is the sign of a copper wire increases linearly with temperature T in degrees Celsius. At 20 Celsius, the resistance is 15 ohms, and at 100 Celsius it is 66 ohms. We have three options, A, B, C. For the first A, it says find the linear function R of T that models the resistance, and B, determine the resistance at 16 Celsius. C, find the temperature at which resistance reaches 75 ohms. Behind of that, under, we see the units to this problem and make it more easier for you. So let's start. Problem one. For the step one, we see that we don't have uh, all of the numbers on only the under numbers, but we will see. For the step one, find the slope m. We have the equation like it is m equals r2 minus r1 divide t2 minus t1. So making the subtraction, it is m equals 56 minus 15 divide 100 minus 20. Like that gives us m equals 16 divide 18. That is 0.2 ohms divide Celsius. For the step 2, find intercept B using R1 equals 15 at T1 equals 20. 15 equals 0.2 under parentheses, between parentheses, 20 plus B to B equals 15 minus 4 equals 46. So R of T equals 0.T plus 46. And it says, I think it's bad the letter, but well, we see. I can see, so I will tell you. R of 16 equals 0.2 of 16 plus 46 equals 12 plus 46. So R of 16 equals 58 ohms. So R of 16 equals 58 ohms. Under that result, it says find T when R equals 75 ohms. So 75 equals 0.2 T plus 46 to 0.2 T equals 29 to T equals 145 Celsius. Well, I think that we can see now. Well, here's the table. It says the results, more like a summary. So we are okay. This is the problem one, and this is it will be the graphic. For the fields, we read the interpretation, like is slope equals 0.2 ohms divide Celsius. Okay, so for every 1 Celsius rise, resistance increase by 0.2. Okay, for 1 increases by 0.2 ohms. At 16 Celsius to R equals 58 ohms, to R equals 75 ohms, to T equals 145. We we are seeing the conversations like if we have the Celsius, we have these ohms, and like that way. For the domain, T equals 0 rate, and range is R 46 ohms. For this way, we are seeing the graphic. It is in here, resistance versus temperature. That is, we are seeing that it's going like a good way, no? It's increasing, and that it's good because we see for every 1 Celsius that increase a little bit, but increases in a graphic. Like when we have a lot of numbers that increase step by step, but it is increasing, so that helps. Well, for the problem 2, we're going to read it. So, trajectory of a projectile. A science student launches a small rocket in a physics experiment. The height h in meters of the rocket above the ground at time in seconds is modeled by h of t equals minus 5t plus 40t plus 2. We have another 3 options, like it says, find the maximum height the rocket reaches and the time it takes. B, determine when the rocket hits the ground, h equals 0. And C, what is the height at t equals 3 seconds? Under that we have the numbers, the values, the quadratic model formula. So we see the problem. Problem 2. Vertex maximum height. T max equals minus b, and all of that numbers. I don't wanted to say it because it's a lot of that. But that result is 82 meters. And the height at 3 equals 3 seconds. H of 3 equals minus 5. Under parentheses, between parentheses, 9 plus 40. Between parentheses, 3 plus 2 equals minus 45 plus 120 plus 2 equals 77 meters. For the step 3, I forgot the step, but do you see in the presentation? Step 3, when does rocket hit ground? H of t equals 0. So if h of t equals 0, t between parentheses, that numbers minus 40 could be plus, could be minus. Between of all of that, 1600 plus 40 divide between parentheses minus 10. All of that gives us an 40.49, oh sorry, 40.497. So t equals between parentheses minus 40 minus 40.497 divide minus 10. That all of that equals 8.05 seconds. Sorry, that is a positive root, like we see in the example that we already see. So here the results, the summary. I said you can see that all of that things are good, are correct, so we can confirm and see. So here's the graphic. I will put it. We'll see. Yeah, it is positive, but in some time of the graphic goes down. It's like a parabola. It's interesting because we see at one point it's the more highest. The number 82 is the best in the graphic. When we use the numbers 2, 3, 7, 62, but it's increasing, but the maximum is 82. So K point, we will see vertex, max, 4 and 82. Highest, like I say, highest point of trajectory, initial height, h of 0 equals 2 meters, lands t equals 8.05 seconds, and h of 3 equals 77 meters. That's still ascending. We will see the number in the graphic, 77. It's not the point highest in this graphic, but when we get the 82, like I say before, it's the highest point in this graphic. So we will say the conclusions. These problems give us a good way to understand more things that the life gives us. We can make a prediction of jobs. It, like I say, it's a prediction. You can prove, you can say, oh, at this point it's going to be better, or at this point it's going to go down the economy, and all of that depends on your money. And if your money goes in a good way, you need to see it. You need to predict in a good way. But it is this is help you. This is gonna help you like a prediction, and that's the conclusion for me. I like this unit. I like these exercises because it's not the normal exercises that I see in the book, but I like it. I put that exercises to not to only to know the words to say, the ohms and Celsius, because that words I forgot in the past, but I remember now. So thank you. I will still learning of these things, and I only want to say you thank you.